Hello, my dear students. Welcome back to the lecture. So now here onwards, we'll try to find the BBS for this particular bar. Okay. So now I'm gonna find the BBS for the green color bar. That is this particular bar, which has gone like this, which has gone like this, and then it has got a bend. So again, this is divided into three parts. First, we'll find this part, then this horizontal part, and the inclined part. Now, luckily, this inclined part length is already given, which is how much? 1150. So don't have to worry about this length. Okay. Now coming to this part, how you'll find this particular part? That is also very simple. They have given you from here to here it is 910, but they have given one more value which is this one. If I bring it down, let me remove everything. They have given you in this particular length, which is at 1050. So this 1050 is this one. From here I'll yeah. So this is 1050. So from this 1050 I'll deduct one cover from this side. Okay, then I'll get this straight portion line. Okay, the straight portion length I'm gonna get. What will happen? Yeah. So this 1050 from here, one cover I'll deduct from here. Okay. So then I'll get this particular straight line. Again, you can take out one small cover even from here also if you want. Otherwise, you can take out only one cover from one side because anyhow, this side the weather exposure will happen. Here there is no exposure, but still to be on the little safer side, what we do, we can deduct another 20 mm because here in the drawing, it may be exactly matching here. Like this value 1150 is up to here, but practically on the slide a small curve will come there. Okay, that is the reason we'll take another 20 mm extra. If you want, you can add it, else it's not an issue. Okay, fine. So 1050 minus one cover from here, minus one is one cover from here, and from here you can deduct another 20 mm from this side. That is fine. Okay, and now coming to the last portion, that is this one. So how we will find this? It's very simple. We know 200 is the thickness of your landing slab. From bottom you take out one cover. From the top you take out one cover. Whatever answer you get, you take 2/3 of that, like we did in the previous cases. Here also this length will come out. Okay. So three things you understood. So directly remember this is 1150. So go to the Excel sheet. I've written this 1150 by default. Then this will be 1050 minus 20 from the left side, minus 20 from the right side. I've done it. And this is 108. How is that? Because 200 is the thickness of your landing slab. Okay, 200. From top, I'll remove 20 cover. From bottom, 20 cover. And whatever answer I get, I'll take 67% of that. That is 160. You take 0.67. You'll get 107.2. You take a round up of this. Okay. After doing that, you'll get 108. What I've done it. Round up 200 minus 20 into 0.67 comma 0 I have done. You get 108. Finish. So what is the name for this? It is top extra bar in longitudinal direction landing level, right? So it's a top extra bar. This is from extra portion. So it is coming in the longitudinal direction. This is at the landing level. So I've written it here. Top extra bar in longitudinal direction in the landing level. So again, what is the diameter of that? It is mentioned here. This bar, that is green color bar. This green color bar is a 12 diameter at 150. This green color, you can see, 12 diameter at 150. So I mentioned 12 diameter at 150. Cutting length will be how much? 1150 plus 1010 plus 108. Then you have to do the bend deduction if you want. One is 90-degree bend here and one is 45 degree. So 2D plus 1D is 3D. So minus 3 into D I have done. So you'll get 2232. Convert this into meter, it is 2.232 meter. Okay, now come to the number of bar. Again, you remember this is a longitudinal reinforcement. So whatever number of bar you got for yellow, whatever number of bar you got for red color, same here also number of bar will remain same. Here also you'll get the 9 number of bar. Else, if you don't want to do in that way, simple calculation you apply. That is round up 1220 is the width of your flight minus both the side cover minus 20 minus 20 divided by spacing of 150 plus 1 if you do, you get 9 number of bar. Simple. So again, total cutting length will be 2.232 into 9 into 1. This will give me 20.08 meter. And since it's a 12 diameter bar, I'll put that in a 12 diameter. So 20.02088 into 0.888 will give me 17.8381. Simple. Fine. So once this is done, beneath that, below that, you have this distribution still going, right? So this top extra bar you have found, but beneath that, under that, your which bar is going? Distribution still is going. Now we'll find the distribution steel cutting length. Again, distribution steel will be put in which direction? Distribution steel will be put in flight in the flight only. That means 1220 is the width of your flight. From here I'll take one cover, from here I'll take out one cover. So same thing I've done it here. Okay, see, 1220 minus left side cover minus right side cover. So 1180 is the cutting length. Got it? Fine. So I written here landing bar in transverse direction. The name is landing bar because this is in a landing level and it will come in the transverse direction, or even you can put it as a distribution reinforcement. So no problem. Again, coming to the this thing, diameter part. So it is mentioned here. It's a 10 diameter bar at 150 center to center spacing. So I mentioned 10 dia at 150. Cutting length will be 1180. In terms of meter, it is 1.18. Again, number of bar also will be how much? Again, number of bar will be how you are going to do that. Wherever this inclined length you have got 1150, in that portion only your landing bar will come, right? Wherever this inclined portion you have got, this one here, right? So under that only your distribution reinforcement will come. This length we know it is 1150. If I divide this by the spacing is how much? 150. So the spacing is how much? 150. And then you add 1 plus 1 if you do, you'll get the number of bar. Okay, got it? No? Same thing I've done it here. Number of bar, what I've done, 1150 divided by spacing, that is 150, and plus 1 if you do, you'll get 9 number of bar. And therefore total cutting length is 1.18 into 9 into 1 if you do, 10.62. And since it's a 10 diameter bar, I'm putting the weight under the 10, 10.62 into 0.617, which will be 6.55 kg. Got it? Now comes the last, another 2 bars are left out. The next bar what I have is this one, which is that this blue color bar. Okay, this blue color bar, can you see, no, this complete thing. Again, this is also divided into 3 portion. One is this portion, then you straight this portion, and then this portion. Again, luckily, not luckily, I mean, most of the time it will be given. This length is directly given to you. That this is how much? 800. From here to here, it is mentioned it is 800. It's very simple. This length I know how to find. Overall depth minus top cover minus bottom cover. Whatever answer you get, you take 2/3 of that. This will be you're going to get. So this is a question now. How we'll find this length? To find this length, we know this is 1150. To find this length, to find this length, this particular length, how we'll find? We know this is 1050. Okay. We know from here, from this center to this part, it is 1050. This is 910 is only up to here. So if you take from here to here up to center of this, it is 1050. From this 1050, I'll deduct one cover from this side. From this 1050, I'll deduct one cover from this side, and your answer is ready. 1050 minus only one cover from this side, because here there is no cover, because this is going in the beam portion. You don't have to do any deduction for this. Okay, getting my point? You don't have to do any deduction for this. So what you will do? Yeah. So what you will do? Come to the Excel sheet. So this is 800 given in the drawing. Directly this is 800 given in the drawing. No worries. This is 108. How is it? Round up. 200 is the thickness of your landing slab minus top cover minus bottom cover into 0.67. If I do 108, same thing I got it here, 108. Same thing here. So this will be how much? 1050 is the width of your stair. I mean 1050 is the width of that landing portion minus one side cover I am going to do. Okay. That means 1050. This is 1050. From here only this side cover if I deduct, I'll get this length. I'll deduct only this cover, 20. So if I do that, I'll get this length. From here to here, this length I'm going to get. That is 1050 minus one cover will give me this particular length. Okay, getting my point, no? Good. Simple. So once you do that, you'll get the answer. Okay, I've written it here. I've written bottom extra bar in longitudinal direction. Why it is bottom extra? Because this is in the bottom direction and it is going longitudinally. So it is called as bottom longitudinal bar in the landing slab, or in the longitudinal direction. If you write also, it's okay. Or you can write at landing level also, it's okay. It's understood. So number of the number of bar is 1. Again, coming to the diameter, check what is mentioned. So it is mentioned you're supposed to provide, so this blue color, right? 12 diameter at 150 center to center spacing. So come here, 12 diameter at 150 center to center spacing. So total cutting length will be 800 plus 1030 plus 108 minus 140 90-degree bend here, that is 2D, and 145-degree bend here. 2D plus 1D is 3D. So minus 3 into 12 you do. So you'll get 1902 mm. So in meter it is 1.902. Now coming to the number of bar, again number of bar, since it's a longitudinal bar, I've already told you, whatever number of bar you got for this yellow, green, this also will be same number of bar because your width of the stair is same. 12, 20, minus 20, minus 20 divided by spacing plus 1. So if you do that, you'll get 9 number of bar. Same thing I've done it here. Minus 20 divided by spacing plus 1. If you do this, you'll get 9 number of bar. So for total cutting length will be 1.902 multiply by 9 and multiply by 1 will be 17.118. Therefore, total weight will be, since it's a 12 diameter bar, under the 12 diameter column, so it will be 17.118 multiplied by 0.888. This will give me 15.20 kg. Got it? Finish. Almost all the part is covered. Last one part is left out. That is the landing level. In the landing level, if you can see, these are the distribution steel what we have provided, right? This steel, can you see? This one, this one, this one. So these are my distribution steel. So if you ask me practically show it, so this is how it looks practically. This steel I'm supposed to find. This one, distribution steel. This I haven't found so far. Okay. So how you will find? It's very simple. Cutting length remains very simple. You should know what is the length of this stair. What is the length of this? From both the side you deduct the cover. One cover from here, one cover from here. You'll get the cutting length of this. We'll try to do that. Go to the drawing. So here it is given 2600. So here it is given 2600 is the length of your landing slab. So from here I'll deduct one cover. From here I'll deduct one cover. 20, 20. If I deduct, I'll get the answer. So 2600. So I'll write here 2600 minus 20 minus 20. So 2560 is a cutting length. That means this bar, whatever you have put practically on the side, let us say this cutting length will be how much? Yeah, this cutting length will be 2560. Okay. In this way, 2560 we are going to cut the bar. But how many bars we require? For that, I need to know this length. If I know this length and if I know the spacing between these two bars, I can find how many such number of bars is required. So for that, what is the length you're supposed to take? For that, we'll go here. Yeah. So how many bars are required? For that, I want to find how many bars are required in this area, right? So in this area, how much bar is required? We know this length is already given. This length is how much? 910. So from this 910, if I remove one cover from this side, I'll get the length. And if I divide that by the spacing, I'll get the number of bar. Very simple. This much you can do. So what I'll do, this length is 910 for us. Okay. From the face of the beam. So beam, you see practically here a beam will come. Here that beam will be there. From this length I want. So this is 910. So in 910, this side cover I'm going to deduct. Anyhow, because here you don't have to deduct any cover. It's a continuous, no? So this is 910. From here it is 910. And from here one cover I'll deduct. And whatever length you get, you divide by the spacing, you'll get the number of bar which you're going to put in this direction. Simple? Fine. So we'll do the same thing now. So 910 minus 20 you do. And what is the distribution steel given? It's a 10 diameter at 150. You can see it here, distribution steel, this one and this one. 10 dia at 150. So I written 10 dia at 150. So cutting length will be 2560 only because it's a straight portion, no bend deduction and all. In terms of meter, it will be 2.56. Now to find the number of bar, I'll do it. Number of bar will be 910 is the length what we have, minus 20 cover. This I'll divide by the spacing. Spacing is 150 plus 1. So 6.93 bars I'm getting. I'll round it up. Okay. So round up, ROUND, round up, bracket open, close, close, and done. So I'm getting 7 number of bar. But why it is 14 here? The reason is that you see here, we have this 7 bar will come in the bottom. Okay. In the same way, 7 bars will come at the top. So what we did, calculation remains the same. So I'll do only for the bottom portion. And if I multiply by the 2, I'll get the number of bar even in the top. So practically, if you want to see this steel, whatever we have put, no, we have this top steel also. In top also we have put 7 number of bar, 3, 4, 5, 6, 7. In the same way, bottom also you can see, it's not possible for you to see here, but in the bottom also your steel will come. In bottom also again another 7 steel will come exactly below that, because two meshes are there. One is because two meshes will come, one over this, bottom of this, one over this, and over that it will come. Okay, that is why in the drawing you can see bottom 1, 2, 3. That is above this particular blue color bar, one distribution steel will come, and below this yellow color distribution steel will come. Okay, so that is why 1, 2, 3, 4, 5, 6, 7 bars will come. So I'll multiply this by 2. So that is the reason 7 I'll multiply by into 2. How much I got? 14. So same thing I got 14 here. Got it, no? Finish. Now cutting length will be 2.56 into 14 into 1 will be 35.84, and total weight it's a 10 diameter bar. So 35.84 into 0.617 will be 22.113. Got it? Simple. So in this way, the entire BBS for the staircase is completed. So I explained you for one flight. Similarly, you can do it for the other flight also. Okay. Now coming to the total weight of the steel. So total weight under the 8 kg, under the 8 mm, there is zero steel. Under 10 mm, you add everything. 49 kg of steel is required. Under 12 mm bar, 95 kg of steel is required. So total will be 49 plus 95 comes out to be 144.843 kg of steel is required. Okay. So if how did I do? You just have to add all the bar under the 8 mm. So in 8 mm we don't have. Under the 10 mm you add everything, like whatever bar you, whatever area you got, no, whatever steel kg you got, you add it. It will come out to be 49. Under the 12 also you do the same thing. You have to add 33 plus 13 plus 14 plus 17 plus 15. If you add everything, you'll get 95 kg. If you add both, you'll get the total steel, which is 144 kg. So as a thumb rule, always remember in the staircase, you usually get 150 to 200 or 250, I'll take, kg of a steel is required in one single flight. Okay. So this is a thumb rule that you need to remember. If the reinforcement is little heavy, it may go to somewhere close to 200. But here we have got almost 144 kg of steel and all. Okay, fine. So always remember that in the staircase, what will happen? Roughly you get 152. I'll write it here if you want. 152, 250 I'll go kg. 250 is on a very higher side, but it's okay. Kg of steel is required per flight. Okay, per flight this much steel will come. So you can take it as a thumb rule, and based on that, even if you don't know to do the BBS for the staircase, you assume around 200 kg of a steel will be gone in the single flight. You check how many flights you have, you multiply that, you will get the total steel that is required in the staircase. But in the staircase, the BBS is little tougher, but the amount of steel which comes in staircase BBS is very less. It's almost like 150 to 200 kg per single flight. Got it? So I got 144 kg here after adding all those things. So that's how the complete BBS for the staircase will be done. Try to practice it once or twice and you can learn all these things. So in the future, if I find some other staircase which I need to add, I'll be adding those staircase also here. But try to practice this. What you do, whatever values I have given, don't take these values while you practice. You take a different value and try to do on your own so that you'll have a understanding of that. Okay, first you practice like what I've explained. Later, instead of taking 152 you take 1600. This you take 2800, and you change this 1350 to 1500. You change this 1140 to 1200. Change all the diameters and all those things so that you can practice. Keep the same model, keep the same. If you want, you can even change all these things. Okay, this landing instead of 910 you keep 1000. You change this landing width to 3000. Stair width also you change it to, like, 1500 and 1500, so that you can practice and prepare your own Excel sheets and you can master the staircase part. So we'll see you back in the next lecture. Thank you.